Are you thinking of creating your own crypto exchange, or let's say your own NFT marketplace where you can generate random NFTs, or let's say you want to create your own blockchain game? If you are thinking to create any of the following things that I mentioned before, then this video will be an important video for you, because in this video, we are going to talk about Oracle. Now, when I'm saying Oracle, I'm not talking about Oracle as a company, but Oracle as a technology, which is a very important thing that every blockchain developer must know if you want to create your own crypto exchange, or let's say your own NFT marketplace, or let's say you want to create your own blockchain game. In this video, we are going to study two Oracle projects. First one, where we are going to fetch the real Ethereum price in USD in our smart contract, and another one where we are going to create our own random number generation smart contract, with the help of which we are going to generate random numbers, which are very useful in your NFT marketplace, in your crypto exchange, as well as in your blockchain games. So I hope you are excited for this video. If you are excited for this video, let me know in the comment section below by saying I am excited. So let's start with oracles. Now it's time to understand what are oracles. Now let us understand oracles with the help of an example. So let's say we have our smart contract and we have this external world. Now the data that is stored on the smart contract or on the blockchain is actually called on-chain data, while the data that is stored on the external world, or I will say on a server, or let's say on a database, means the data that is stored not on the blockchain is actually off-chain data. So by the name you can easily understand that it is a off-chain data because it is stored not on the blockchain, and it is on-chain data because it is stored on the blockchain, right? And there are times when we want to have this off-chain data. There are times when we want to create decentralized application and we want to fetch this off-chain data, means the data that is stored not on the blockchain. Like for example, let's say you are creating your own crypto exchange. Now in your own crypto exchange, you want to fetch the real, let's say Ethereum price, or the real Bitcoin price, like the real time price, right? What is going on in the market. Or let's say you want to create a decentralized application, and this decentralized application is actually fetching the weather data, right? So this weather data is something which is not stored on the blockchain, it is stored on a server, or let's say on a database, right? And we want to fetch this data so that we can create our decentralized application. Or let's say, for example, you want to generate some random numbers. Now you might find this strange, right? Like, why do I need to generate random number? But there are times, let's say you are creating a game, for example, let's say you are creating a casino game, or for example, or any other game, because random number is a very important part in game generation, right? So in that particular case also, you require this random number generation, and this random number generation is not possible on the blockchain. And I will tell you about this why, but for now, just take my word that random number generation is not possible in blockchain, or I will say it is possible in blockchain, but it is not secure. Okay, but we will talk about it in our upcoming slides. Now the question arises that how we are going to connect these two different worlds, because this is a blockchain world and this is your non-blockchain world. So how we are going to connect these two different worlds? And the answer to this question is we are going to connect these two different worlds by using a bridge, and that bridge is nothing but Oracle. So this Oracle will be acting as a bridge between your on-chain data, between your blockchain world, and between your off-chain data, that is your non-blockchain world, so that you can easily send data from on-chain to off-chain and from off-chain to on-chain. And this is the importance of oracles. It actually help you in connecting, means it actually help your blockchain to connect from this off-chain, or I will say to this external environment. Okay, so that you can use the data produced by this external environment in your blockchain environment. So if you have to define oracles which are systems that can provide external data sources to Ethereum smart contract. So these external data sources are actually your off-chain data. Ideally, if we talk about oracles, oracles are systems that are trustless, means these are those systems that you can, I will say, blindly trust. Okay, so these are actually trustless, meaning that they do not need to be trusted because they operate on decentralized principles. But there are oracles which are actually centralized in nature as well, but we will talk about it in our upcoming slide. But for now, if we talk about an ideal scenario, your oracles are something which are totally trustless, means you can trust them without even thinking anything. Okay, I know you must be thinking like, how this can, like, why we will be trusting some oracle, how I am going to trust that oracle. We will talk about all these things in our upcoming slide, but for now you have to take this ideal situation. Okay, now if we talk about some functions of oracles, some key functions of all oracles, so there are actually three key functions. First one is collect data from an off-chain source. To collect data from an off-chain source, transfer the data on chain with a signed message, means let's say if you are getting some data from this off-chain source, from this oracles, okay, so this oracle will actually sign that data, that okay, this is the data that I have actually provided you, like it is to provide you authenticity that okay, I am the one who is actually providing you with this data, so that we can, if something goes wrong, we can, go to that person and say, okay, you have signed this particular message, and then make the data available by putting it in a smart contract storage. So it actually helps us in making the data available on the smart contract storage, and you will see this how it actually happens when we will actually fetch the price of the ether, the real-time ether price in our smart contract. Now there is this question always that people have in mind, that what are actually oracles? If we have to define them, like what are they? So oracles can be anything. Oracles can be a software, oracle can be a human, or oracle can be your hardware. So oracle can be anything, software, hardware, or a human. So for example, let's say you want to fetch the percentage. Let's say you went to a university and now you want to fetch some data from your university so that you can store it on blockchain. Now in this case, your university will be working as an oracle, because you are actually putting your trust on your university, that okay, your university is going to provide you the correct data. And most of the cases we trust our universities, right, that our universities will not actually lie to us and they will actually provide us the correct data. That's why we have got our degree, right? So that's why, as I said, oracles can be anything. So it can be your software, it can be a human, or it can be a hardware as well. Now the only thing that matters at the end of the day is that oracles need to be secure. So they can be either software, they can be either human, or they can be either hardware, they can be anything, but the only thing that matters at the end of the day is that they need to be secure, okay, because these are actually third-party application that we are using to get the data from an external source, and we are going to feed this data to our blockchain, right? So the only thing that matters is security. Now let us understand how this ether price fetching actually takes place whenever we are actually using oracle, and then we are actually going to code this particular smart contract and we are going to fetch the data, the real-time data of Ethereum price. Okay, so this is, let's say, your DeFi application that you have created. So this is your front end. Okay, you have created this beautiful front end which actually reflects the prices of all the cryptocurrency, and then you will connect this front end with your smart contract. Now there will be time definitely when you want to fetch the data, real-time data of the Ethereum, right? Because this ether price is not present on the blockchain, but it is actually stored on a server, or let's say, or in a particular database we do not know about, right? So what we will do is we will simply make a request from this smart contract to this oracle, and this is a trustless system, and this oracle will actually provide us with this Ethereum price, and then we are going to use this in our smart contract, and then we can show this to our customers. And oracles are very important, plays a very important part in this particular case, because do not be confused that oracles are just simply APIs. No, they are not simply APIs. These are something more than API, because they are actually providing you with a lot of security. You are actually trusting them, and they are actually providing you with a real-time data. That's the most important thing about oracles, right? Because if there will be some issue with the Ethereum price, then it will actually cause a huge amount of loss to traders, and your cryptocurrency market can went down. So oracles plays a very important role whenever you are creating your own DeFi application. Now let's talk about the types of oracles that we have. So we basically have two types of oracles. First one is your centralized oracle, and this centralized oracle example is Oracleize. So you can use Oracleize in order to fetch different off-chain data. The only thing that you need to understand is that Oracleize is a centralized oracle. Since it is a centralized oracle, means we are actually giving some centralized authority to, we are actually trusting some centralized authority to fetch the data, right? Now definitely you can go for Oracleize, because Oracleize actually uses some good techniques in order to secure your data, to provide you trustworthy data, like for example authenticity of proof and TLS not reproof. But we are not going in depth of these two different things, authenticity of proof or TLS notary, because in this lecture we are going to focus on decentralized oracle, because the whole point of blockchain is decentralization, right? So why we are going to use some technology which actually, which is actually using some centralized kind of I will say technology. I'm not against that. Definitely, you can still, various projects are using it. You can also use it. But in this, for this particular lecture, I'm going to focus on decentralized Oracle. And the best example of decentralized Oracle is Chainlink. And this is the heart that I'm showing so that I can tell the love for decentralized applications. So we are going to focus on decentralization in this lecture. Now, the best example of decentralized Oracle, I think, currently, or the most famous one, is Chainlink. So, this is the symbol of Chainlink, and in this particular lecture, we are going to understand how Chainlink works, and then we are going to go to our project part. Now, as I told you in the previous picture, that how you can use Oracle in order to fetch the price for the smart contract. Now, instead of for the project part, we are going to use Chainlink as an Oracle to fetch this Ethereum price. Now, what is this Chainlink? So, Chainlink is a decentralized blockchain oracle network built on Ethereum. So, this is perfect for our situation because this is a decentralized blockchain oracle. So, it is decentralized in nature. Second thing is, the network is intended to be used to facilitate the transfer of tamper-proof data from chain sources to on-chain smart contracts. Now, Chainlink as a technology actually providing us with a tamper-proof data, which is actually very important because we are trusting a third party, right? Definitely this third party is a decentralized network, but still it is a third party. So Chainlink actually help us in providing this tamper-proof data. And the third thing is this diagram, which actually shows how Chainlink is actually acting as a, I will say as a middleman, not actually as a middleman actually, but how Chainlink is actually helping us in connecting with this off-chain source. So this is your off-chain source. There are so many different, players in this off-chain source. So there are different, I will say, people, companies who are participating as an oracle. And then Chainlink is actually checking all these different parties, and from these different parties is actually providing us with the real-time price or whatever data that is required to our blockchain. So this is the best thing about Chainlink because it is actually making sure that we are getting the correct data from these decentralized peers, or I will say decentralized companies who are actually participating in order to provide the data. So if you will visit chain.link, this particular website, I will share the link of this website. You can see that how Chainlink is actually using these oracles in order to fetch the real-time price of Ether in USD. So if you will see, the real-time price of Ether is $1,859.05, right? And if you will see, all these oracles are actually stating very close value to it, right? If you will see this node 0.1, let me zoom in a little bit so that you can see as well. So if you will see this particular company, so it is actually reflecting a data of 1859.10, which is 0.05 close to it, and then it is 0.09, 0.06. So you can see that we have these 31 oracles who are actually participating in order to provide the real-time price of Ethereum, and then Chainlink is aggregating all these data. So it is taking the median of all these data and providing you with this particular value. So in this way, it is a decentralized in nature, and Chainlink is actually helping you in providing with a authentic data here. Okay, and not only that, if you will just go down, so here if you will see, these are the oracle responses, and we need at least 21 people who are actually stating the same value. Means if 21 out of 31 are saying that okay, the real-time price of Ether is this, so Chainlink is going to believe them, not the rest who are just providing you with some false data or something like that. Okay, and you can see that these are the people who are actually active in nature. These are the legend, right? And if you will go below, you can see there is this contract address, and I will talk about it when we are going to create the smart contract in order to fetch this Ethereum price. Okay, and if you will go a little bit down, so you will see these are the different oracles, right? Oracle and the value, at which time this is showing the real-time Ether price, and these are the users who are actually using Chainlink, right, in order to fetch the price or whatever they are doing with Chainlink. Okay, and if you will see Ether price in USD on Google as well, it is close to it, right? It is 1859.05 and it is 1864.00. It is very close, just a deviation of 0.05, and I think they have shown this as well, that deviation threshold is around 0.5%. So you can trust on Chainlink in this particular regard, not actually Chainlink, but on all these people who are actually providing you with this real-time data of Ether. So now it's time to fetch real Ethereum price in our smart contract. And how we are going to do that? We are going to do that with the help of this Chainlink. Okay, so let's start with this. So in the first phase, what we are going to do is we are going to create an aggregate v3 interface type of variable. Okay, and you will understand why. So let me name this as price feed. Okay, and then we will have our constructor. Okay, and inside this we will have the price feed. Okay, so we are going to create an instance of, and inside this price feed, because this price feed is type of aggregate v3 interface, right? So we are going to create an object using this aggregate v3 interface, and inside this we are going to provide this address. Okay, now this address that you are seeing on my screen is actually a address of aggregate v3 contract. So if I will show you this, so if you will go to Etherscan for the Sepolia test network and paste this contract address that I have copied from here. Okay, so you will see that this is a deployed smart contract on this Sepolia Etherscan. Okay, so I'm using this smart contract in order to create this instance. Okay, this instance, and I'm going to provide this instance to this price feed, because this price feed is also of type aggregate v3 interface. And now with the help of this instance that we have actually created using this aggregate v3 interface, and I have actually assigned it to price feed, we are going to fetch the real Ethereum price. So you must be thinking like how I got this address, right? So it is given on Chainlink docs. If you will go to Chainlink docs, docs.chainlink.link data feeds means this particular segment, then you will see that Chainlink has actually provided with all the addresses. Okay, so we have these different addresses. If you will see, it is for Ethereum mainnet. So in our case, we are using Sepolia test network because we do not want to spend any money, right? Otherwise, we need to spend money if we want to use it on Ethereum. Otherwise we need to spend money if we want to use it, if you want to use this Ethereum mainnet, right? And for this Ethereum mainnet, you will see that we have different contract addresses. Now these different contract addresses is for different currencies. So it is for ETH, if you will see, means ETH in NCH. Then we have this NCH in USD. I do not know what is this. I think 1 inch is what is this 1 inch, but I'm not sure about that. But you will see that we have these different units, and for these different units we have this different price segment, I will say. Okay, so if you will just go below, you will see that we have this Bitcoin in USD, then we have BNB in ETH. Okay, so we have different cryptocurrencies under different units. And if you will just go down below a little bit more, you will see we have this Sepolia testnet, and for this Sepolia testnet we also have the BTC ETH price, then BTC USD price. And what we are doing is we are actually using this address, that is ETH/USD, means we are fetching the price of Ethereum in USD. And I think I have copied a wrong address, if I'm not wrong, sorry for that. So I think if I'm fetching the price of Ethereum in USD, then I need to copy this down. I think they have given in their documentation the old price. I do not know why, but okay, I think this is the address that we need to copy. Okay, so let me remove the address. Okay, I got it. Actually, by mistake, what I have done is I have copied the BTC USD price. So if you will see, 0 cross 1BB 1B44 is for the BTC. So BTC price in USD, but we are going to fetch for Ethereum. So I'm going to paste this here. Okay, and now what we will do, we will simply create one function by the name of get latest price. Let me make this public, view returns, since we want the price of the Ethereum, so we will have int here, and then we will simply have the price value. And to get the price value, we will have this small bracket, then inside this we will have int price, then again one comma, another comma, then another comma. Actually, if you will go to this Chainlink contracts, this particular link, And in the GitHub repo, you will find that this, since the thing that we are using is, we are going to call this latest round data function. Okay, we are going to call this latest round data function, and this latest round data function is going to provide us with these 5 different values. But in our case, we only want one value, and value that we want is the price, right? The answer value. So we do not want the round ID, we do not want these 2 values, these 3 values. We only want the price of the ether, right? So in our case, what we are going to do is, we are simply going to mute, I will say, these values, means we are not going to fetch those values. So that's why these are empty, then comma, then we want the price, so that's why this is int price. Definitely you can name this variable anything else you want. Then we have the this blank space that you're seeing, right? It is for this is started at, then we have this updated data in another blank value, and then at the end we have this answer in round. So if you want to know about these, you can just check the documentation of Chainlink and you will be able to find more about it. But for now, I'm going to just fetch the price, and I'm going to use the price feed instance, and then I'm going to call the latest round function, round data function, actually round data function. Okay, and then what I'm going to do is, I'm going to simply return the price that we have fetched, and by this we are actually ready to go. This is the only thing that we need to do. So I will simply deploy this. Okay, and since we are using Sepolia test network, right, so I need to connect my MetaMask. Okay, so I will type my password. Let me select Sepolia test network. If you haven't used Sepolia test network, then I will suggest you just go to your settings, just go to your networks, and then go to your add network field. I'm going to Sepolia test network, but you have to go to add network, and then simply copy paste these things. Okay, and while copy pasting, if you are using it for the first time, you might be asked to log in to Infura, because this is using the Infura API key. So you need to log in, and once you will do that, you will be able to use Sepolia test network, and then you have to simply go to the faucet and you can simply fetch the ether from it. Okay, so let me select one address that have some amount of test ether. So this value I'm going to select, it has one Sepolia ETH, and now I'm going to simply deploy it. Remember, do deploy it on Sepolia test network only. Do not deploy it on any other test network, otherwise it will not give you the correct result, because we are connected to Sepolia test network because it is actually having the address of the contract that is deployed on Sepolia test network. So I need to connect it to my MetaMask, and now we are connected. Now we need to deploy it. So let me confirm it. Let's wait for our transaction to get confirmed. Okay, so we have our smart contract, and in this you will see this get latest price. I'm going to call this, and hooray, so we do have the real-time Ethereum price. You might be thinking, okay, I do not think so this is the real Ethereum price. This looks very different, but it is. Let me show you. So if you will see, the current Ethereum price is 1863.05, right? And if you will just compare it, okay, and if you will compare it, you will simply see that it is 18665. It is 1863.05, means there is a simple, I will say, round off is done. So after 1866 dot, you can think of that here is a dot. And why are you not seeing any dot here? The reason is very simple, because our Solidity smart contract does not support floating point value. We do not like Solidity does not support decimal values. So, and since this does not support decimal value, you are not seeing any decimal value. So you have to simply fetch the value, and the value that you will be getting is in the integer format. And then when you are going to show this value on the front end, you need to convert this value again back to decimal. But in our case, we are just designing the smart contract. We are not going to the decentralized application part. So I think this is good, and it's a very simple process, guys. You have to simply use some JavaScript functions, and you can simply convert this value back to a decimal value. Okay, but for now, this is the fun part. We have actually fetched the real-time ether price from Oracle, and we have actually transferred it in our smart contract. So this is what we were talking about since we started, and now it's time to go to our next project, where we are going to see how to generate random numbers using oracles. Now the first question that arises is, what is the purpose of generating random numbers, right? Like, why do we need to generate random numbers? And the answer to this question is very simple. Let's say if you want to create your own NFT marketplace, or let's say if you want to create your own NFT website. In that particular case, let's say if you want to generate some random NFTs. Now, in that case, you require random numbers, right? And let's say, for example, you want to create some game. And if we talk about games, everything in game is totally random, right? Let's say if someone is hitting a bullet to you, or let's say if you're jumping, whatever you are doing, there are some random scenarios attached to the game. And in that case, also, you require random numbers. So you can understand why random numbers are so important when it comes to blockchain. And if you remember our lottery smart contract that I have created on CodeEater Web3 channel, then you must have seen that in order to create this random number for this lottery smart contract, I was using this function, right? And during the creation of this lottery smart contract, I told you that you should not use this random function when it is a production level code. Okay, for definitely for learning purposes it's good, but you cannot use the same code whenever you want to generate random numbers. And the reason for it is very simple. Let us understand why. See, the thing with random numbers is that they need to be random. That's the beauty of random numbers, right? If they are not random, if someone can predict the random numbers, then they are not random, they are because predictable, right? And if you will see this particular code in this, there are a lot of values which are actually predictable in nature. For example, block.difficulty. Now this is something which is very much known to everyone, right? Especially if you are a miner, you know that what is the current block.difficulty, or you can predict actually like what might be or what can be the block.difficulty in the coming future. Okay, then we have this block.timestamp. Again, this is something which you can predict, right? Because, and especially if you are a miner, let's say for example, if you are a miner, then block.timestamp is something that you can actually control a little bit, but you can still control this block.timestamp. And if you can control this block.timestamp, then you can also get a predictable result. So let's say if you want to be a part of this lottery smart contract, and a miner is there also who is also participating in this lottery smart contract. So by manipulating this block.timestamp, miner can easily win this lottery. And I hope nobody wants to be a part of lottery where the results are already predictable, right? And then we have this players or tent. Again, this is something which is very much predictable. So you can clearly see that in our smart contract, the random number that we are using is totally predictable. It is something which is not random number at all. It is totally predictable number. And this poses a great threat to our lottery smart contract, right? So what is the solution of this, right? And we are going to talk about that in our upcoming slide. Now let us discuss two reasons that you should not. Now let us discuss two reasons that you must not use random number generation in your smart contract. So if you are thinking that I understand from your smart contract that while creating a random number like this there will be difficulty, but still I want to create my own random number in my smart contract. But let me tell you that then you will be in trouble. Now why? First thing is that you might be in consensus issue. What is this consensus issue? We will talk about it. And another thing that we'd already talked about is miner manipulation, because miner can easily manipulate your smart contract because you are using certain parameters which are totally predictable, which are totally manipulated, which can be totally manipulated by the miner. Now, what is this consensus issue, right? So let's say we have this node, okay, because as we already know that in a blockchain network we have so many different nodes, right? So let's say we have this node A and we have this node B, okay, and let's say in our blockchain we created a smart contract. Now this is smart contract. Since this is smart contract is created on a blockchain, then this is smart contract will be will go to A, right, for the verification, because this is a transaction because we will have a lot of transaction in our smart contract, right? So for verification and validation purpose, this smart contract will go to node A as well as node B, or you can think that transactions will go to node A and node B, right, because there can be so many different nodes in a blockchain network. Now during the verification part, when node A runs your random function, which is a part of your smart contract, and again we have this random this random function will also be present in this node B smart contract as well, right, because this is the same smart contract, right, which is distributed all across the network so that verification and validation can take place properly. Now during the verification part, when node A ran this random function, the result that node A got is 5. And since this is a random number, when node B ran this random function, the result that B got was 99. Now you can clearly see that we have some issue here, right? Because for node A, the random function is generating 5, but for node B, the same random function is actually generating, okay, I think the spelling is wrong, right? Do not just forget about it. The same random function is generating 99. So we can clearly see that there is no consensus between these two different nodes. And just imagine a situation when you have so many different nodes, thousands of nodes who are participating in your blockchain network, and when they are going for this verification of your random function, what they found is all of them are actually generating some different result. So they will never reach to consensus, or if they will reach to consensus, definitely it will be a time taking process, because they need to wait for a particular value, and until only that particular value is same for at least, let's say, 51% of the people, they will never reach to the consensus. Hence it will increase the cost, right? It will increase your I will say the network congestion will increase, because most of the time they will be using, they will be running your random function so that they can get the consensus, reach to the consensus. Now, another issue that we have seen is miner manipulation. So as we have seen this particular screenshot, that miner can easily manipulate this block.timestamp, and this is a problem, right? So if a miner already know that, okay, this random number is using a parameter, let's say block.timestamp, so I must mine this particular smart contract at a time when I will be the winner of this lottery smart contract. And this is actually a great threat to the lottery smart contract, right? Because miner is able to call the random function and is able to generate a desired result, the desired result that miner actually wants. So what is the solution, right? We have talked about the problems, like we have been talking about the problem, right? But what is the solution? How we can improve the situation? What is the solution, right? And the solution to this problem is Oracle. Now, instead of generating a random number on our smart contract, what we can do is we can use this random function on oracles, right? Now, by this, what we are doing is we are simply shifting this random function from our smart contract to this random function, like to this oracle, right? So if, let's say, for example, miner is calling this random function, so instead of generating the random function within the smart contract, this smart contract will make a call to oracle and say, hey oracle, I need this random function because this is asked by this user, okay, this xyz user, so can you please generate a random number, and can you please provide me with that random number? So oracle will say, yes, I will. So oracle will provide the result, and then a smart contract will provide the same result to the miner or whatever person is actually calling this random function. Now by this, miner will never be able to know the source of random number generation, right? Because miner does not know anything about this oracle, right? Because this oracle is like a black box to miner, because miner is a part of blockchain network, not the part of this oracle, right? Because oracle is a third party thing, right? It's the third party thing, so miner does not know about it. And by this, we can resolve the problem of random number generation on the smart contract. So instead of generating random number on the smart contract, we will be using oracles, which will act as our friend and generating the random number, and then we are going to pass this random number to the person who has actually asked for it. So now it's time to generate our own random number using Chainlink Oracle. Now I am at this particular section, subscription method, and inside this I am at this get a random number, okay, and I will share the link in the description of this video so that you can access this directly. And if I will go below it, you will see that first of all, in order to use Chainlink Oracle, we need to create a subscription. Now this is a step where you are actually, just like if you are using some service, you need to have a subscription of it, right? So in the same way, we are doing that. So just click on this particular button. Now once you will click on it, you will see this particular dashboard. And if you are not already connected, then you need to connect it to your MetaMask wallet. Let me do it for you so that you can also see. Let me lock my account for now so that I can show you the complete process. So if I will refresh it for now, so if you will see that it is saying that detecting wallet, now connect wallet, just I accept MetaMask, and then just provide your MetaMask wallet password. Now once you will do that, you will see a dashboard which might look a little bit different from me, but don't worry, these are the subscription that I have created in the past. One I have created just some 1 hour before actually. And how you have to do is you have to simply click on this create subscription button. Okay, just click on this. Now once you will click, you will see that this is your admin address, means this is the address from which you are connected. Okay, so I'm connected to this particular address, so that's why this is my admin address. And I will simply click on create subscription. Now these two fields are optional. If you want to fill it, you can, but I will leave it as it is, and I will simply click on create subscription. So you can see that as soon as I have clicked on that, I am seeing this message. I have to confirm this on my MetaMask wallet, and this, with the help of this, my subscription will be created. So we have to wait for this transaction to get confirmed. So by creating the subscription, we will have this subscription ID, which we will be using whenever we need to generate our random number. So you do not need to do this step again and again. This is just like you are paying for a subscription, and now you have the ID, and you can use this ID again and again whenever you want to generate this random number. Okay, and let's say if you want to create a new project, then you can definitely create a new subscription, and then you can again start with the same process. So you can see that this transaction is successful. If you will go back, you can see that subscription created, and in this we have to click on this add funds option. Now once you will click on this add funds option, if you have just in my case, if you will see, if in my case I already have 15 link. Now this 15 link is actually chain link token. Just like for Ethereum we have ETH, for Bitcoin we have BTC. In the same way, for Chainlink, in order to use Chainlink, okay, Oracle, we need this link token. So if you already have this link token, then that's great. If you do not have it, just click on the Chainlink faucet and then simply complete these steps. Okay, first of all, provide your wallet address at which you want the link token to be transferred, and then you can simply do a verification that you are a human by logging your Twitter ID, then simply doing I am human, and then you can send some link tokens in your wallet. Now once the link token will be transferred in your wallet, you will be seeing I will show you this balance. Okay, that your wallet balance is 15 link or whatever link. Like in the first step, when you will do this, you will be transferred with 20 test link, which you might not see in your MetaMask wallet. So do not get worried if you're not seeing that. Okay, I'm not seeing any link token in my wallet. That's not an issue. Once you will do this transaction successful, once you will see that okay, this transaction is successful, if you will go back to your subscription, you will see that your wallet balance is updated. Okay, and once it is updated, you have to simply provide add funds. Now this add fund is something like from your MetaMask wallet, which is having your link token. From your MetaMask wallet, it will be transferred to your subscription, so that you can use this link token when you are generating your random number. I know it sounds a little bit complicated. The only thing that we are doing here is, now after creating the subscription ID, now I am funding my subscription. Okay, so that whenever I'm using this subscription ID, my fund is attached to this subscription ID, and I can use the subscription ID wherever I want. Okay, so something like that. And then I will simply do 10 here, and I will just click on add funds. Now this step will be only possible when you have tokens, link token. If you do not have link token, it will not be successful. Okay, remember this. You need to have a wallet balance. And just click on confirm. So this is confirm. So sending 10 link to your subscription, as you can see from the message that it is sending 10 link to our subscription ID, and just close it, or you can simply go to the transaction to see whether it is successful or not. Okay, so this is successful. If you will go back, we will close this, and if you will again go back to the dashboard. So to go to the dashboard, I think we need to go to this. I'm clicking on this. So you will see that okay, I have this 10 link in my subscription ID 1138. So this is the subscription ID that I have created, and this subscription ID is funded with 10 link. Okay, so in the first step we have created the subscription ID. In the second step, if you have link token, that's good. If you do not have link token, then go to the link faucet and transfer some link token to your MetaMask wallet. And in the third step, we have simply funded our subscription ID with this link token. Now we are ready to go, and we are ready to create our own random generation smart contract. Now in order to generate our random number, we are going to use Chainlink smart contract, which is actually provided by Chainlink. So you can see this is smart contract which is given here. Okay, so we have tons of lines, right? So different functions, different variables, so many different variables, right? So do not worry. I will be explaining you each and everything what is given here so that you can easily use this smart contract in order to generate your random number. So let's say if you're creating your lottery smart contract or whatever you are trying to do with random numbers, you can easily do with this smart contract. So in order to explain you this, what I will be doing is I will be simply copy pasting certain lines of code. So and I will be explaining you all those lines of code so that it is not it does not look messy. I can simply explain you this whole code right here only, like this only, but I think it will make the matter much more complicated, and I do not want you to feel that. So what I will do is I will simply copy paste certain lines of code and I will be pasting in the remix id, and I will be explaining you each and every thing that is given in the code so that you can easily use this smart contract whenever you want. So let me place this screen to my second screen, okay, in my second window. And now let me copy paste this first line of code from it. So it is contract vrf v2 consumer, which is actually inheriting these two different contracts. Now these two different contracts, if you will see, we have imported these two contracts right above this particular line. Like we are actually importing vrf consumer base v2 here, and we are using it, and then we have this confirmed owner.sol, and we are again using it. Now if I will have this curly braces, you will see that we have this error, and the error is because I think most of the time, like I haven't seen these contracts, but I think these contracts are actually abstract in nature. So let me see that as well. So let me paste this down. Let me go to this. Okay, I think so. Like what they are trying to do is they are actually they are inheriting from some abstract contract, what I think. The reason why I'm saying this is because if I will click this error, you will see that type error contract vrf v2 consumer should be marked as abstract. Now this mainly occurs whenever you are if you are inheriting an abstract contract. So to remove this error, for now I will be using a shortcut, okay, and I will be just using an abstract keyword here just to remove this error because it looks pretty annoying. And when we will be done with this contract, then I will be removing this abstract so that it does not give us the same error, because after we will be using all the functions, then we will be implementing all the functions from this abstract contract, then this error will be gone. Okay, so this is the concept of abstract contract, but I am explaining you what is actually all about abstract contract. Okay, so now if I will copy paste the second line of code, which is all about events that we are going to emit, this request sent event and then this request fulfill event, and we will be using them when we will be emitting them in one of those functions which we will be creating. Okay, and then I will simply use another variable, or not variable, actually data type, that is struct. Now this is struct is a special data type, I will say, not actually special, but yes, it is an important data type, because in this we are actually having all the information related to our request. So whether our request is fulfilled or not, whether our request actually exists or not, and then the request means whatever random words, means whatever random number we have inside this random words array. Okay, so this is what we have done actually. So by doing this request status, we have actually created this type of structure where we have this fulfilled, where we are going to have a bool type value, then exist, a bool type value, and then this we will have our random words. Okay, so this is a dynamic array. I have just created 3 slots, but it is dynamic in nature. Okay, so it will have as many slots as we want. Now another important thing to notice here is that we have these two different variables, right? First one is fulfilled, and then we have this exist. Now this exist will be true, when we will be calling the request random function. Okay, and we will be seeing that once we will start with the code. So request random words. Now this request random words function will be actually helping us in generating a request id. Okay, so this is something to do with the request id. It will not be generating your random words, but it will be generating your request id. So once your request id will be generated, okay, using this request random word function, okay, so then your exist part will become true. Okay, so this will become true. Now fulfilled will be still false, so initially, because we are not initializing it, so it is false, right? So this is the rule of solidity. If you are not initializing a variable, it's by default value. Since it is a bool type value, so it is by default false. So during the request random function, we will be making this exist true, not this fulfilled. We will be making this fulfilled true when we will be, not actually we will be, this fulfill random function, fulfill random words function, which will actually we will be creating, okay, this fulfill random words function, which will be called internally. So we will not be calling it, it will be called internally. This fulfill random words function will actually make this true. So this fulfill random words will check, okay, whether we have the request ID or not, and once we have the request ID and the random words, we will be making it true. So I'm just explaining you beforehand this so that you are not confused, like why we have these two different variables, this exist and fulfilled. So fulfilled, to like when we have the request that we have made, when it is totally fulfilled, then we are going to make it true. Now this exists, this is for the ID part, so this is related to your ID and this is related to your random words. Okay, so that's why we have these two different variables. And don't worry, we are going to see these two functions, so don't worry if you are not getting by any chance any of these two things. Let me paste this mapping. Now this mapping is from uint data type to our request status struct, right? So this mapping is like a dictionary, or I will say like a notebook, which is actually having all the information regarding all the request status that we will be creating. So whenever we will be creating our request status, then we will be inserting those request status inside our mapping so that we can refer them later. Okay, so this is how our mapping looks like. Okay, so we have this uint data type, which will have all the request IDs that we will be generating, okay, using this request random words function, which we have talked earlier as well. And this will be our request status, right? This will be the struct that will be actually inserting inside this mapping. So in the starting, if you will see, it will be false, and in the starting we do not have any random words because we are not initializing, so it will be totally empty. There will be no slot inside this random words array, right? So this is how it will look. Your request mapping will look. Okay, then we have these variables. Okay, now these variables, if you will see, first we have this coordinator variable, which is of VRF coordinator v2 interface type, the contract that we are importing here. Okay, now this variable which will be actually helping us in actually getting the random number. Okay, so we will be creating an instance of this VRF v2 consumer, VRF coordinator v2 interface, and then from this instance we will be calling the functions that are given in that particular instance, just like in our previous smart contract where we actually created our when we were actually fetching the real-time ether price, right? So we were using this instance, right? And then with the help of this instance we were calling the functions in order to get this price feed. In the same way we are going to do that. Okay, then we have this subscription ID, and in this we will be having the subscription ID that we have actually created just before this, right? And then we have these two different variables. The first one is request ID, which is actually of a dynamic array of uint type, and inside this we will be having all the request IDs. So whenever we will be making any request, okay, so that request will have a ID, and we are going to store that ID inside this request ID. So just like we have students and every student has a roll number, right? Have a roll number. In the same way we are doing for the request status. Okay, we are assigning an ID to it. And then we have this last request ID. So let's say if you have let's say created made some 5 requests. Okay, now this 5th one will be having an ID, right? So we are storing this last request ID inside this last request ID variable. And then we have these variables. Okay, and these variables, if you will see, we have this bytes 32 key hash. Okay, now this is the key hash for the gas. So let me show you. So if I will go to again chain link, and if I will go under this section supported networks, you will see that for 30 GUI, okay, for 30 GUI key hash is given as this value, and if you will match it, you will see the same value is given here, 0x474, and this is also given here. Like for every situation, let's say if you will go to Ethereum mainnet, for 200 GUI you have this key hash, for 500 GUI you have this key hash, and for 1000 GUI you have this key hash. Okay, and we will be passing these key hash when we will be sending the request, and you will see that. Then we have this callback gas limit. So in our smart contract, we will be creating this fulfill random words function, okay, which will be making some internal calls. And for that, we are actually having this maximum gas limit so that our internal our transaction does not fail. Okay, so it is actually telling you that storing each word, like each word means each random word that we are generating, cost you around 20,000 gas. So for as a safe limit, they are actually having this 1 lakh or 100,000 of gas so that your transaction does not fail in the middle. Okay, so if you are actually thinking, okay, I want to reduce this, definitely you can reduce it, but in that case the chances are that your transaction might fail. So that's why they are providing you this safe limit of using this 1 lakh. And then we have this request confirmation variable. Now this is for the confirmation, okay, this random number that is generated, whether it is correct or not. So we are actually confirming it. So just like in blockchain, we have this 6 blocks confirmation, right? In the same way, these random numbers when will be generated, we are actually waiting for the confirmation that okay, this random number that is generated is correct. Okay, and then we have this number words, means the number of words that we want to fetch at once. So what actually Chainlink suggests is that whenever you are making a request, so every request will cost you some money. So they are saying that it's better to get at least 2 random numbers in a one request, so it will actually be gas friendly to you. Okay, otherwise you can have only 1 random words at once, it's up to you. But Chainlink says that in one request, if you are getting 2 random values, it is good for you, it will cost you less amount of gas. Okay, so that's why we have this number of words too. Definitely you can increase it and decrease it, but then you have to make changes in the smart contract accordingly. Okay, now if we will go down, we have this constructor. Now this constructor is all about if you will see, it is actually first of all creating this instance. Okay, and this is the hard coded value. Okay, this is provided by Chainlink. So as we have seen in the price feed smart contract as well, right? We have this fixed smart contract address, and this is for Sepolia test networks. Okay, so they have provided this comment as well, if you will read it, that this is for Sepolia test network. So if you are using main network, in that case this will change. If you are using Gorilla test network, then it will change. Okay, for Sepolia, this is the desired address, because this will be actually helpful in calling this random function which is given on the Oracle. Then we are actually having this subscription ID, and we will be passing our subscription ID here, and we are actually initializing this S subscription ID that we have created above, right? This subscription ID. And also here also we are doing is we are actually calling the constructor of VRF consumer base v2 and initializing with this address, and then we are actually confirming the owner, means the person who will be deploying this smart contract will be the owner of this smart contract. So we are actually providing the address of the message.sender, means the person who is deploying the smart contract, and he will become the owner of this smart contract. Okay, and if you will go below, you have this random request random words function. Okay, and if you will see, it is called by only the owner of this contract, nobody else can call it, only the owner of this contract can call it. And who is the owner? The person who will be deploying this smart contract. And then if you will just go down, you will have this request ID. Okay, and if you will see, we are using the coordinator here, right? We are using this coordinator instance, and we are calling this request random words from this instance. Okay, and then we are passing the key hash that we have provided, the subscription ID that we have provided, the request confirmation, the callback gas limit, and the number of words. So as I said, you can change any of these values according to your situation, according to your need, and then you will be calling this request random words using this coordinator, okay, that we have instantiated. And we are feeding this to the request ID. So this will be returning us with a request ID, and we are using this request ID in order to fetch the details whenever we want to again see, okay, what random number I have generated for this request ID or this request ID. So you will see here also that we have this S request. If you remember, we have created this mapping. And inside this, we are actually whatever request we are creating, we are actually inserting it inside the S request ID mapping. Okay, and inside this, if you will see, we are passing these values like random words, and for now in the starting, it is empty, right? It is an empty array. Then exist, yes, request do exist for now, so it is true. But Is it fulfilled? No, it is not fulfilled. Means still the request is not fulfilled. We have made a request, but it is still not fulfilled. And then we have this request IDs, and we are using this request ID array in order to push this request ID. Then we have this last request ID, means whatever who will be called, like whenever the last call will be made to this function, that last request ID will be fetched inside this last request ID variable. And then if you will see, we are simply emitting this request sent with the request ID and the number of words. Okay, and then we are returning the request ID. So by this we will be getting the request ID by calling this request random words function. Okay, and then after which we have this fulfill random words, and when we will be calling this fulfill random words, we are actually providing the request ID which we have generated here, right, in the above function, and the random words. Okay, so the random words will be provided to this fulfill random words function, and this is an internal function, guys. Okay, this is not something that you will be calling. This is something which will be called internally. Okay, so you do not have to worry who is calling this for now, but this is something which is being called internally. So no one is calling it outside the smart contract. We will not be calling it. It is being called internally only. So we are importing so many contracts, right? So they must be calling this internally. We are not going in depth of that because it is a very complicated matter for now. So for now we will be having this fulfill random words, and what this is doing is, inside this you will see we have when this internal call is made, we are providing the request ID, the random words that are generated. Okay, so we are providing all these these two different things, and once this is done, we are simply checking whether this request ID exists or not. Means we are checking for this. So first, in the starting, we will be calling this request status. Okay, this we will be calling this request random words in the starting, and once this request is made, okay, so we will have a request ID. So once this request will be helpful in fetching the random words, then we are going to call this fulfill random words. This will be called internally with the request ID as well as with the random words, and this request ID will be checked whether we have actually generated this request ID or not. And then if it is generated, means if it is true, then we are going to the next line, and we are simply using the mapping in order to make the fulfillment true. So when we were making the request in the starting, the fulfillment was false because we were simply making a request. We were not getting the random words in this particular function. We were simply making a request, and once this request is fulfilled with the random words and the request ID, then we are actually making it true. So we are simply calling the struct, right? Since we are storing the struct inside the mapping, we are simply checking for the fulfilled, and we are actually making it true. And then you will see that we are actually also inserting the request ID like this with this struct that we are storing with the random words that are passed inside this fulfill random words function, and then we are simply emitting these two different things. So let me explain you this with the help of an example, like what fulfill random words is actually doing. So when we call this request random words function, right, so we made this exist part true, right? We made this exist part true, and this is what we are checking. If you remember, this is what we are checking inside this, that whether the request ID exists or not. So we are simply pointing with the help of this mapping, because we have the request ID. Let's say the request ID is 0 for now. So for request ID 0, if you will see, so for request ID 0, whether the request status, so whether the request status is true or not. So by doing like this, when we do like this, request and then 0, so we are simply pointing towards this structure, and then we are checking this structure by doing this. So we are checking this exist variable, which is this exist member, which is inside the structure, by doing this dot operation, because if we want to access any member of a structure, then we use this dot operator, right? So we are simply doing s request 0, which is actually pointing to the struct, then we are doing dot exist, then we are pointing towards this value, and we are checking whether it is true or not. If it is true, means the request exists, then we are going to make this fulfilled also true, and in this way we are fetching and in this random words we are actually having all the random words, all the random values that we generated. For example, it will be a very long value, but for now let me have some small values like 23 or let's say 100, something like that. Some random values will be here when the fulfilled function will be called. And then at the end, we have this get request status function, with the help of which we can get the status of our request. So we have to pass the request ID that we will be generating using this request random words function. Okay, so once we have the request ID, we can check whether it is fulfilled or not, or whatever the status is. So first of all, it will check whether the request exists or not. If the request exists, then we are going to have our s request ID, means we are going to transfer whatever is inside the mapping, right? So whatever is inside this mapping, this, let's say for a request ID 0, we have this struct, so we will be passing this inside this request. Okay, so this request variable, which is of type request status, and request status is a struct, right? So we can do that. So we are going to pass this struct from this mapping to this request status, means to this request variable, which will be pointing to our mapping, and then we will start checking like whether it is fulfilled or not by doing request dot fulfilled and by doing request dot random words. So in simple words, what we are doing is we are simply, so when we are doing like this s request, and let's say for s request 0, we are actually transferring this to request variable, right? To this request variable, which is of type struct type, right? This is struct type that we created. Then this request will be pointing towards the struct, okay, to this struct like this, and it will be checking whether request dot fulfilled, means this fulfilled, this is what it, like it is simply check, right, whether it is true or false and whether it exists or not. So we are simply doing this with this with the help of this request, because this request is also pointing towards this struct, and we are simply doing request dot struct, like request dot fulfilled, and by this we are actually able to have the access of this variable and have the access of this exist when we are doing dot exist. Okay, like this. And with this, we have completed our random function smart contract, and we can now remove this abstract. Okay, let me remove this, otherwise it will not get deployed. So by this, if you will see, we have completed our random function smart contract, and now it's time to check it whether it is properly working or not, right? So now it's time to deploy our smart contract on Sepolia test network, right? And remember to deploy it on Sepolia test network only, because the coordinator address that we are using is for Sepolia test network. So what we will be doing is we will be connecting our remix ID with MetaMask. So if I will open my MetaMask, you can see that this is my account address 0A2C. So this is the connected account address with my remix ID as well. And now I have to provide my subscription ID. Now in order to fetch my subscription ID, I will simply go back to Chainlink, just simply go to this get a random number, and inside this just open the subscription manager. And once you will open it, you will see this dashboard, right? Now inside this dashboard, if you remember, I have created this subscription ID, right? Remember yesterday, I think I have created this one only. So I will be simply clicking on this subscription ID, and now I will be copying my subscription ID from here, and I will be providing it here. Okay, since I want to use this subscription ID in order to in order to generate my random number. So I will simply click on deploy, and now I will confirm this. Now we need to wait for some time so that the smart contract get deployed on the Sepolia test network. Now if I will go down a little bit, you will see that we have these various functions, right, that we have created inside our smart contract. And you will not find this fulfilled random words function, because this is an internal function, as you can see. So it will not be seen here. And now if I will try to use this smart contract, you will see that I will not be able to. So if I will call, let's say, this request random function, you will see that it is throwing us with an error that you will not be able to, like, you cannot call this function. Now why this is happening? This is happening because if I will go back to the dashboard, you can see that this is my subscription ID, right? But if I want that someone can use my subscription, the subscription that I have provided this with, like the subscription with which I have funded this with 10 link, right? If I want that someone should use my subscription, in that case I need to add that particular contract address here. Okay, unless I will not add the contract address here, nobody will be able to use this subscription ID. And this is just to so that nobody is using the subscription ID without your permission. It's something like that. So what I will do is I will simply click on add consumer, and inside this I will simply copy paste the contract address by which I am giving this smart contract an authority to use my subscription. So again I need to do this transaction, confirm it. Now again, we need to wait for some time for this transaction to get confirmed. Let me see on Block Explorer. So it is taking some time. Okay, so now the transaction is confirmed. Now if I will go back and if I will click on this request random function, you will see it is not throwing any error. Now we need to confirm this transaction. So by this, we are generating the request ID, right? Let me zoom out a little bit. So by this, we are actually generating the request ID. So once this transaction will be confirmed, we will be seeing our request ID. Again, let me go on Block Explorer to see whether this transaction is confirmed or not. Okay, so this transaction is confirmed. And if I will click on this last request ID, you will see that request ID is generated. This is pretty big, right? This is a huge number. So this is our request ID, which is a totally random request ID. And now what we need to do is we need to use this request ID in order to check whether we have our random words or not. Because as I said, this request random words function is only generating the request ID, right? It is not generating the random function. Random functions means random words. So random words will only be generated when this fulfilled random words will be totally called and when this fulfilled is true. So let us check this. Let me copy paste this. Let me go to status part and let me call this. So you can clearly see that for now, the fulfillment of our random word is not done yet. Means what it's saying is that it is taking some time for our random number to be generated. So it is a time taking process. It will take some time for your random number to be generated. So you have to wait for some time until or unless this value is true. When this value will be true, in that case, you can check your random word. So for now, let me call this again. So now you can clearly see that as soon as I call this again, our fulfillment is true, means random word is generated. And you can clearly see that it is showing us the random words as well. So if you will see, this is our random word. And since in a call, we have called for two random numbers, so you will see that after comma, this is our first random word, this is our first random number, and this is our second random number. And you can clearly see that they are totally different from each other and they are pretty big random numbers, right? And with this, we have completed our tutorial of generating random numbers in Solidity. And you can use the same contract in your lottery smart contract as well. So remember, we have created our lottery smart contract. So in this random function smart contract, in this lottery smart contract, actually, we have created this random function, right? So I want you to replace this random function with the new random function method that we have seen for now. Okay. And I want you to do that. This is your assignment. And I want to tag me at Twitter or LinkedIn. I will share that with you to me like, okay, I have created this lottery smart contract using the Oracle concept that you have taught. Okay. So this is your assignment, guys. Do not miss your assignment. I want you to do that. Okay. And whenever you want to add some more contract into your subscription, you have to simply click on this add consumer button, just paste the address of that consumer address, means that contract address, and it will be added to your subscription. Let me refresh it for now. So you will see that for this subscription ID 1138, this is the smart contract that we have added. And again, if you want to add some more, just click on add consumer and you can add some more smart contract address. So you do not have to do this again and again. And one thing more important thing to notice here is that it is also showing us the fulfillments. There is a number of fulfillment is 1. And you can clearly see that some amount of link token has been detected from our subscription during the get random function call, right? When we were doing the random word generation, during that, some amount of tokens has been detected from our account. So this is the importance of funding our subscription using link token. So I hope you enjoyed this video and I hope you learned a lot from this video. We created 2 projects from scratch. One was our random verification function and another one was fetching the real Ethereum price, real-time Ethereum price using oracles. So if you enjoyed this video, if you have learned from this video, please do like, share and subscribe this channel because I'm regularly going to upload new blockchain courses on this channel. These are my LinkedIn ID as well as my Instagram ID. Do not forget to share your assignment with me. Tag me on LinkedIn or let's say on Twitter, tag by tagging that, okay, I have completed this particular assignment as you mentioned in the video. With this, we are going to end this video. I hope you enjoyed this video. Meet you soon in the next video. Till then, take care. Bye-bye.